It is my great pleasure as President of EUCAMS to welcome you to this online meeting, eYCN ECC, organized by the European Young Chemistry Network, the eYCN, which is a part of EUCAMS. Therefore, let me just briefly remind you or tell you what EUCAMS is. EUCAMS is a supranational organization that coordinates the work of 42 chemical societies belonging to 33 different countries from Europe, but also Israel, Turkey, and Russia. We are organized in the so-called professional networks, which include divisions that cover all disciplines of chemistry and also working parties. eYCN, the European Young Chemistry Network, is a part of us, a very important one, I have to say. And let me take this opportunity to thank them for organizing this event and also for inviting me to give the opening address. Our mission is to increase the visibility of chemistry at the European level by speaking with one single voice and to foster a European common identity among the chemical societies. We also provide scientific advice to better inform decision makers for their policy making work, and we are committed to present chemistry as an essential and indispensable provider of solutions for global challenges to the general public. To fulfill our mission, we are engaged in a variety of activities, such as participation in policy debates, we publish position papers, we organize workshops in the European Parliament, and we also have a very well-established scheme for awarding prizes that we do for personalities, for individual scientists, also to historical landmarks, and we also have specific schemes for early career researchers. So let me take this opportunity to just remind you the two main schemes that we have. One is the eYCA, the European Young Chemist Award, which the final will take place tomorrow and to which you are all cordially invited. And the other one is the EUCAMS Lecture Award, which is sort of aimed at the early research career students, well, not students, already postdocs that have finished their PhD thesis not after 10 years. So that's also a scheme that sometimes is not as well known as the eYCA, but I encourage you also to participate in these prizes, which are, the applications are every year. And another important thing that we do is, of course, the ECC Congress, the European Chemistry Congress, which takes place every 2 years. And as Alice said, this year it was scheduled to take place in a couple of days in Lisbon. But of course, due to the pandemic, we had to postpone this. And this is going to take place finally in 2022, also in Lisbon. At these ECC Congresses, it's a tradition that eYCN organizes an important event, and they also coordinate many activities for the general public. So this webinar that is going to take place today is in a way what should have taken place in Lisbon if we had had the chance to celebrate it online, sorry, face-to-face. So having participated in many of these special symposium organized by eYCN at the ECC Congresses, I encourage you to take part in this one, in the following one, and to be very interactive and very active, because I can assure you that you are going to learn a lot. So I think that is all from my part. Once again, thanks eYCN for organizing the event. Thanks eYCN for allowing me once more to take part in their activities. And I will just now hand the floor to Alice Solda, who will briefly take care of the program. Thank you very much.
Thanks a lot, Pilar, for the nice introduction. And thanks also to all the attendees to be part of this event. I'm really happy. Of course, as you might imagine, it would be even nicer to be in Lisbon altogether, but okay, this is what it is, and now we take also the advantage of having these amazing speakers available for us to show you the, let's say, a lot of topics, and in this particular session related to the future in chemistry. So this session is going to be chaired by João Borges. He's our delegate from Portugal. So I'm really happy to have him on board. Please, João, thanks.
Thank you very much, Alicia and Pilar, for this nice introduction. So I am João Borges. I am a eYCN member, and I am very pleased to share this first session on the future in chemistry. As Alicia and Pilar mentioned, of course, it was very nice to meet you in Lisbon. Of course, this is not possible, but we hope that in 2022 you come back to the 8th ECC. So first of all, let me welcome you to this first session. And I would like in particular to thank all the speakers that you see here in the slide for their availability and for joining us in this event. So as you see in this session, we'll be talking about the future in chemistry. So what will be the role of chemistry that will play in the near future? And for that, we'll cover different topics ranging from teaching in chemistry, digital research and development, new opportunities in under the new Horizon Europe framework program of the European Union, as well as recycling. And for that, I would like to mention that we'll be having these 4 speakers, please bear in mind that you as attendee can direct any questions to them during their talk. So you should write in the Q&A tab all the questions that you may have for each of them during their talks, and then I will be reading the questions at the end of each talk. So I'm very pleased to introduce the first speaker. The first speaker is Menno. Menno is a chemistry teacher at the ROC van Amsterdam, which is a school devoted to vocational education. And he's also looking for implementing new educational tools and strategies to teach with the students and have fun in chemistry together with the students. He's really passionate about chemistry, and he's a long-time supporter and education advisor for eYCN. Last but not least, you might have heard about Professor Kem Chicken. He was the creator of this official mascot of eYCN. And today you'll be talking about teaching in chemistry with a talk entitled "Future Your Proof Classroom: Teaching Skills 2030." So Menno, you have 20 minutes. Please allow a few minutes for the audience to make you some questions. So the webinar is yours, Menno.
Thank you, João. All the compliments. I'm blushing. It's cool. Thank you for this opportunity to share my ideas about teaching chemistry. And it's not only about teaching chemistry, it's also about giving presentations and having fun in doing online presentations. It's quite different than doing presentations or teaching in real life. I prefer real life. But there's also quite some to do in online teaching. So future-proof your classroom, teaching skills 2030. And let's see what we can do in approximately 10 minutes. So most of the time I plan 10 minutes and I will talk 15. So like a real teacher. The topics are practice like you like, recyclability, Maslow, the pyramid, 3 tools I will tell you something about you can use during presentations or online teaching, how to cheat, and questions. Now the questions, I hope you have questions because questions make the presentation a lot more fun. So if you have any questions, please type them in the Q&A. Practice like you like. It's a bit like practice how you teach or preach. For me, it's practice how you teach. If you are looking or are making a presentation, especially an online presentation, think about the time people are spending behind the screen. especially in the last few months during Corona times, people are sitting behind their laptops, behind their monitors, more and more time than normal. And your eyes are not used to these kind of lights or the amount of light. Monitor light is quite different than the lights on the ceiling or the lights outside. So think about how eyes respond to colors. Now, when I give an online presentation, I mostly use dark colors, a dark background to give eyes some rest. If you use a bright white presentation, your eyes get tired. I think most of you feel at the end of a working day more tired in your eyes than you physically are tired. So think about the screen time and the colors you use, and make sure you have some time between presentations. If you're a teacher and students are switching classes, normally they walk from one room to the other room and have approximately 5 minutes of eye rest. And now they switch from one meeting, one Teams or Zoom meeting, to another, and they don't have a small rest or a walk. So make sure your students or listeners have a small pause and can walk a bit, move, and stop watching at the screen. Because when you watch the screen too much or see the screen too much, you will fall asleep, your eyes get tired. And I've been falling asleep during some lessons of colleagues, and I was really ashamed. And the last thing, eat, sleep, drink, repeat. Make sure when you're teaching online, have a drink. It's not gin, it's water. You have enough sleep and eat. When you do those 3 things, small things, you will be sure your quality of teaching online will improve. And the first time when you see the drawing, it is rubbish. You're spending so much time preparing your presentation and giving the presentation, and you will see it's not exactly as you like it. And practice more and more and more, and you will see you'll improve your skills, your online teaching skills or presentation skills, presenting skills, and you'll get better and better and better. And at the end, they will say, wow, it was perfect. I want to do it like you're doing it. Like I said, it takes more time to prepare an online presentation or class or lessons than when you do it in real life. Real life teaching is getting more and more and more like a second nature. You have done it the same thing last month or last year. You can get your stuff from the archive and give it again. Online teaching takes more time because you don't see your viewers directly. They're not in the same room with you. So you want to do more. And especially when you do demonstrations or make some tasks for students to make, it takes more time to make it online. So make sure the things you make and think of, you can recycle them for next year, next month. Make them small like Lego blocks. And with the small Lego blocks, you can build new things without making something new. So record your lessons. Record everything you do online. You can use different tools for it. In approximately 5 minutes, I will tell you about it. Store the things you make. And not like I do, store them and forget where you store them. Record, store, and keep on repeating them, and especially look around and share. you're not the only one making a presentation or making a lesson about pH or titrations. Look around, because other people make a lot of stuff, and some, it's still a minor group, share the things they make. And when you do the same, share the things you make with others, a larger community are sharing the things they make, and everyone can use it. And as a community, we get better and better and better and spend less time in making new things or the same things. One of the organizations who is using sharing and accessibility as a key point is Xerte. It's a project from the Nottingham University, and they it became too big, so they brought it in a foundation. So it's not commercial, but it will exist eternally. And in Xerte you can make everything. It's like a small website editor. And the cool thing about Xerte is you can implement it in digital learning environments. And you can find quite some Xertes online with ready-to-use lessons. I'm using it now to make a course about chromatography in 3 stages. And I can use it again and again and again. And 4 other schools in the Netherlands are using it too. But before you're going to make something, we're going back to the things people need. Now, Maslow is one of the scientists who made something. The 5 needs of human. And 2 of them are quite difficult to achieve now during these Corona times. And I think in future when, I think a big part of teaching and presentations will stay online, are missing esteem and love or belonging. When you're in a classroom or in a lecture theater, you can see everyone, and you can, with small signs, you can notice people, looking them straight into the eyes, or saying yes, or pointing at them. You notice them, and when someone feels noticed, they feel belonged, and when they feel belonged, safety increases and esteem increases. It's difficult to achieve online because the only people I see is myself now in the webcam, and the other from the panel turned off their webcam, so I feel a bit alone. So make sure you use things like esteem. Oh, where's my mouse? There. Esteem and love, belonging, not too much love, to achieve it. Now, during Corona times, toilet paper was added. Quite, needed. I don't know how it was in other countries, but in the Netherlands, all the toilet paper in the beginning of the Corona crisis was, in the Netherlands, we call it hamstring. It was all gone. People were buying too much toilet rolls. But still, it's like, people are fleeing. They feel something is missing. They feel not safe, and they're doing something to feel safe. So they store toilet paper, not white toilet paper. There are quite some other things you need. So make sure in your class, during your teaching, you see the people. You notice the people. Just before I started my presentation, I was looking in the attendees list, and I saw some familiar people, like a friend, Simon. I'm still wondering how you do the magic tricks with the cards. Thank you. Just notice the people you know and acknowledge the people you don't know and thank them for attending your talk. Now, the 3 teaching tools. To make all those things a bit easier, you can use tools, online tools, because you're not in a classroom, you're not contacting students or attendees directly. You need something else where they can work together, make their own community, and you can directly see what they're doing. One of my favorite things is Padlet. A Padlet is like a big board with a big pin board, and you can put all kinds of things in it. As a teacher or presenter, you can make your own empty board and give your listeners a task and say, here's the link to Padlet, and just make a brainstorm or other ideas you can see here. What can Google Sites do? And yeah, it's perfectly for brainstorming or seeing what their knowledge already is, so you can go further on it. The next one, my all-time favorite, Mentimeter, where Padlet is perfect to use simultaneously with your online presentation. Mentimeter is a bit more difficult, but it's perfect to use after your class or after your presentation. When you want to check their knowledge, want to check or make them practice with the knowledge you taught them, you can use Mentimeter. And Mentimeter is a kind like an online interactive presentation method where students or attendees can online give answers. And as the host or the maker of the Mentimeter, you can see directly the answers the people give and help them or teach them immediately if something goes wrong. If they have some wrong ideas or thinking path, you can steer them directly to the good one. Mentimeter, and some people use Kahoot, are tools you use next to your laptop. When you use Mentimeter as a presenter, people see the questions on their laptop screen, and the easiest thing to do is to let the listeners, students, or anyone use Mentimeter on their mobile phone, so they can see the screen of the laptop, computer, and the questions they give on their telephone. That's the best thing. I tried it to do it online, but people are switching between the presenting screen and their Mentimeter screen, and they hated it. And this thing, the digital learning environment, it's getting more and more and more and more and more important. Books are old. I like books very much, but things are going online, and the digital learning environment is most of the time a safe way to make students or others learn. In the digital learning environment, they can see the presentation back, and you can build it like a house, and complete courses are made in the digital learning environment. And things like Moodle, Canvas, LearnBeat, Blackboard, those are examples of learning environments. SharePoint, it's more like document storage, but some people are able to use it as learning environment, are examples on making it. And I could tell you a lot more about the digital learning environment, but I only have little amount of time. But to fill your learning environment or to make a course, here are some resources you can use. LibreText has a special chapter for chemistry classes, all kinds of levels, ready to use, And the thing I love about this one, it has an export, and you can use it to import it in your own learning environment. So Canvas and Moodle are working directly together, and all the tasks in these classes or these courses are going into the learning record store. So all the scores and levels are recorded. So you can, as a teacher, you can see what they are doing. Chemistry Explained is less interactive, but also good. And Royal Society of Chemistry has a perfect and wonderful department on interactive courses. But as a teacher, you have to cheat. And be careful with cheating, because they will see it. The thing I really, really, really hate and love are demonstrations. I like to do demonstrations in the classroom. And in the classroom, I have time to prepare it, to do the demonstration, and to talk about it. And online, it's difficult, because when a demonstration, most of the time with me, fails, I have to do it again, and all the attention of the students, our listeners, is gone. So the thing I do now is record the demonstration as a preparation, make a video of it, and show the video during the class I teach. So it makes things a bit easier, and you can record it with your telephone. It doesn't have to be very fancy. Keep it safe. Use GIFs. I use them in two ways, like protocols to fill a volumetric flask, or making solutions. You can make a GIF of it. It's quite big ones, but you can see the protocol, the steps you have to do over and over and over again. It doesn't have to be a movie, but just make it a GIF. And when something goes wrong,
Sorry, Menno.
it's fun.
2 minutes.
2 minutes.
Yes.
Okay. Record everything you do. Oh yeah, the second way I use a GIF, I made a video of myself and use it as a background in Zoom. So I can skip some meetings and people think I'm still listening, but that's really cheating. And be careful with the cheating. People will see it. And if they see it, oh, think about this. Now, students are almost like judges, they kill you. Questions? Oh, yeah, if you want to know more, contact me, especially about the digital learning environments. You can email me or call me or send Alice an email. Thank you. And thank you all for organizing this.
Thank you very much, Menno, for this great talk and interactive tools towards teaching. So we have some questions. Can you talk a bit more about Mentimeter? I know that this was a short talk, but there are some attendees that would like to know if it is like a survey, how it works on.
With Mentimeter, you can import your PowerPoint presentation and add some interactive questions, and different kinds of questions you can add, like multiple choice or open questions, a word field, all kinds of things. And as the host of Mentimeter, you go through the presentations, and simultaneously the students or listeners see the presentation go by. When you push the button, they will all see the next slide. So the tip with Mentimeter is make your presentation in PowerPoint, import it in Mentimeter, and add the questions.
Okay, thank you very much. So the next one is, what is the best tool to make clouds words?
MindMeister. MindMeister.com is a digital tool where you can make word clouds but also brainstorm fields. They have several options to make the cloud. You can use it for yourself, or you can use it in groups, and it works online.
Okay, that's great. Thank you. So I have a few more questions. So what is the most important skill that you think that a teacher should have in the future?
Keep it personal. Keep personal contact with students. So notice them, acknowledge them, even when you can't see them.
Thank you. So, and this will be even more important in the time that we are currently facing, and as you mentioned, so this will be important also in the future.
Yeah.
And to end up, so what is the biggest challenge you have faced to date, and do you think that we'll face in the future while doing your teaching classes?
Sorry, can you repeat that?
What is the biggest challenge that you have
the biggest
faced?
challenge?
Yes, in conveying your message to your students.
I think the biggest challenge in teaching is to is not losing the students, because I think everyone can remember during their study, sometimes you need some pressure to keep on going, and when you're not, when you don't have to go to school or to university, it makes the step smaller to just skip things. And yeah, everyone needs some pressure to go further. And the thing is, how do we provide the pressure?
Yeah, that's totally true. So to end up, we have two questions. The first one will be, can you repeat the digital learning environment platforms?
Moodle, Canvas, Xerte, LearnBeat, Blackboard, and there are quite some really small ones. But when you Google on digital learning environments, you will find them. Even Google has a digital learning, Google Classroom. But be careful with the privacy. And that's
Yes.
a warning for teachers. You're collecting, when you use a digital learning environment, you're collecting data, and be careful with the data.
Thank you, Menno. So the last question is Shirt, I don't know if I am spelling it correctly, is Shirt accessible across all countries?
It's an open source. So if you're technical, you can download it from the website and put it on a server and maintain it yourself. I'm not that technical, so I'm being helped by a bureau who makes it for me. So the technical part, all the programming is done for me, and I'm doing the writing. So on the website xerte.co.uk or .org.uk, you can find more information, and for most countries, which bureau or party can help you with it.
Okay, thank you very much, Menno, for this great interactive talk. So I would ask also the audience, for the sake of time, we have to move, but if you have any questions, you can also inquire directly Menno through his email. It is shown in the slide. I think you will be happy to answer.
Always.
Thank you very much, Menno.
Thank you.
Okay, so the next speaker. The next speaker will be Gunter Hermann. So Gunter is an entrepreneur from Berlin. He obtained his bachelor, master, and PhD studies from Freie Universität Berlin. The PhD was in theoretical chemistry. He is really a passionate theoretical chemistry and experienced scientist. So after finishing his PhD, he co-founded together with two other colleagues the startup Quantum on Demand. which aims to provide automated and resource-efficient R&D solutions based on artificial intelligence and quantum simulations. So today, Gunter will talk about the digital future of chemistry based on artificial intelligence and quantum chemical simulations, with a talk entitled Digital Future of R&D, Chemical Predictions based on AI and quantum chemical simulations. So Gunter, please, when you are ready.
Yeah, I'm ready. Can you hear me?
Yes.
Yeah, okay. Thank you very much for this nice introduction. So I have to switch to my presentation. Okay. So I also want to thank the organizers for inviting me to this webinar, and I also want to welcome the audience. And I hope that my really bright presentation would not make your eyes tired. Today I want to talk about why the usage of chemical simulation can accelerate the R&D of new chemical and pharmaceutical products. Nowadays, we are facing greater challenges, like how can we stop or weaken the climate change? How can we solve our energy problem? Or how can we feed an ever-growing world population? An answer to a part of these questions are new innovations and new chemical and pharmaceutical products. For example, we need to develop more efficient batteries for the storage of renewable energies, or environmentally friendly fertilizers for large-scale agriculture. The development of new chemical and pharmaceutical products is mainly conducted in the lab. However, these laboratory experiments are very cost-intensive and time-consuming, reaching up to several millions dollars and several years for the development of a new drug. Additionally, they are also prone to errors, leading to a huge number of necessary lab experiments for success. These problems can be addressed by using chemical simulations. With chemical simulations, it is possible to predict parts of experiments or to pre-select molecules and materials with the most promising properties for a specific application. So for example, if you want to develop a new solar cell, you can define 100 possible candidates, and the chemical simulation will tell you which are the most promising with the best absorption properties. And these most promising ones you can then synthesize and process in the lab. This will drastically reduce the number of necessary lab experiments, will shorten the development cycles for the new product, and will drastically reduce the R&D costs. However, there are some challenges to overcome if you want to use chemical simulations in R&D. First of all, you need high expertise and know-how to install and to use the highly specialized simulation software. It's also necessary to have a really complex infrastructure to execute the simulation software. This can be very expensive to buy and to maintain. In many cases, you also need not a single simulation software, but a few of them, and you have to combine them to predict a certain chemical property. For example, if you want to predict an NMR spectra on a really accurate way, you have first of all use molecular dynamics to calculate all conformations of a certain molecule. Then you have to evaluate the ones which are important for the NMR spectra, and then you calculate with quantum chemistry the chemical shifts, for example, for the hydrogen molecules. And additionally to the chemical simulations, the results are highly use case specific and are generally not easy to evaluate. That's why we developed our cloud-based software as a service solution called Cloud, with our solution, we want to democratize the usage of computer simulations in the chemical and pharmaceutical industry. So our simulation can be used to automatically predict the properties of molecules or materials. So as I said, for example, if you want to develop a fertilizer, you can, prior to the lab, you can predict the toxicity of a certain molecule or of a certain number of molecules. Then in the chemical simulations, you have certain steps which you have to fulfill to get to the prediction of a certain property. We have automated the whole workflow of such a simulation for specific use cases. So for example, for an NMR spectra, you just have to define the structure of a molecule, and then we calculate all things which are necessary to get you to provide you with a valuable NMR spectra. In order to provide the user with a really accurate and efficient prediction model, we combine machine learning methods with computational chemistry. This not only enables you to efficiently predict the properties, but also to predict properties like the odor of a molecule or the toxicity of a molecule, because these properties are not available from standard computational chemistry methods. Our solution is easily accessible via our web application, which you can see on the right-hand side. And it can also be easily integrated in the toolchain of a lab chemist, so that you can integrate our service in an electronic lab journal. So this is also really important, so that the lab chemist don't have to change his whole tool change just to incorporate chemical simulations. As I said, we want to really provide you with efficient and accurate prediction models. That's why our models are based on 3 main elements. First of all, the computational chemistry. So here, quantum chemistry and molecular chemistry, molecular dynamics. We created fully automated workflows for the preparation, execution, and evaluation of these simulation techniques, so that you just have to define your system, so material or a molecule or reaction, and then get your result at the end without knowing what's in between, or you don't have to know this. However, the computational chemistry methods are sometimes really slow and time consuming. That's the reason why we are incorporating machine learning methods like deep neural networks or convolutional neural networks. This really depends on the use case, which method we choose. And we learn these machine learning methods for specific properties like the odor or a spectra. And for this training, we are using simulation data, which we have for millions of molecules on a DFT level. And we are using freely accessible experimental data like spectra, odor, or the toxicity data of molecules. These 3 elements we combine in our custom prediction models, which then can be easily used and which are integrated in fully automated workflows, as I said. One of these workflows is the workflow for the odor prediction. Imagine you're working on a new product or molecule where the odor is really important for your customer or for your boss. And with our solutions, you just have to enter the structure of the molecule, and then with our prediction models, you get the odor descriptors as a result. These predictions are based on machine learning models. And with these results, you can then adapt your molecular structure to modify its odor. At the end, yeah.
Sorry, 2 minutes. You are.
Yeah, I'm pretty at the end. At the end, I would shortly introduce our team, because I'm not developing our product on my own. This is Marcel, Vincent, Christian, and me. Vincent is responsible for the automation of the quantum chemistry and molecular dynamics methods. Christian is developing the machine learning models and is accumulating the whole data from simulations and also from the experiments. And Marcel and I are responsible for the development of the algorithms and the scientific development of our product. And now I want to thank you for your attention. If you have any questions, you can ask now or send me an email. And if you like, you can visit our website. Thank you very much.
Thank you very much, Gunter, for this great talk on combining the molecular dynamics, artificial intelligence, machine learning with experimental data. So we do have a few questions.
Yes.
So the first one, so you mentioned the cloud-based software that you are using in your company, and you can predict the physical properties of different materials, right?
Yes.
So this allows you to reduce the costs and the time that you need to for the synthesis of new materials. So this is really an added value for different labs. So how can this software be integrated into different devices, into different labs? How can you integrate it?
This is via our API. So we have an interface which you can easily access, and then you can use it in your electronic lab journal or with a lab device. Stuff like this.
Okay, thank you very much. So we have two more questions. Can you please briefly describe about your journey from a PhD student to setting up your own company?
Yes. So our idea really, I really studied from the bachelor with Marcel and Vincent, and during our PhD we have this idea to just give the chemists in the lab a tool where they can automatically predict the properties of molecules, because they often came to us and asked, hey, can you calculate the UV spectra for us? So these are really standard problems for quantum chemists. So we wanted to give them a tool where can do this by their own without knowing which method I have to use, which basis set, how I have to evaluate the results. So this was the starting point for our company. And then in 2018, we started with a so-called Berliner Startup Stipendium. It's a scholarship for half a year. And we continued with another scholarship, which is called the Exist Gründerstipendium. And in 2008, we found a GmbH, so really a company. And now we are searching of, we develop our product so that the industry can use this.
Okay, thank you. So we have two more final questions. So next one will be from Albink. Next, I hope I pronounced it correctly. So very nice presentation. I am curious about the case of nanomaterials. How can you model and predict the toxicity of these materials? To have precise control of size, shape, and so on.
Thank you very much for the question and also for your comment. Yes, we are really at the start. So we can predict it for smaller molecules, and now our toxicity predictions rely really on data which you can access from the internet. So I think we have to establish a combined method between quantum chemistry in order to evaluate or to calculate the structure and electronic structure of the nanoclusters, and then I think you need experimental data to judge this. I don't think this is, this is not yet really possible with our product. So, but I think if you know the structures, then you can make some conclusions from this where it could be toxic or stuff like this, but it's not yet possible with our product.
Okay, thank you. So, and the final question is from Sabino. So prediction model based on quantum mechanics and machine learning are considering for experimental researcher as a black box. How it is possible to change this point of view, especially in catalysis? So the interest here is in catalysis field.
I don't understand the question. So why are we using black box for? So
yeah.
So as you can tell, I don't get the point. So I can just say, so if you are a catalyst, you want to somehow improve your catalytic compound, then you have, as I said, you have a bunch of a few candidates which you want to improve in your lab, and then perhaps you can beforehand you can improve their properties by changing their structure, and this would be a black box method. So you say, okay, I want this, I have this catalyst and I want it to absorb sunlight in this and this region. What can I do? And then our product would suggest, okay, here you need an hydroxyl group or stuff like this.
Yeah, I think also.
I don't know if this answers the question.
I think here the point was also to distinguish between the experimental research and the one that we do while doing chemical simulations. So there is here those that do the experimental and are not really familiar. It's not so easy to integrate this kind of concepts. And I think that maybe this is the direction of the question. Yes.
Okay. Yeah, we have to more or less a little bit change their minds that they have to define their problem. Then we can give them a bunch of answers, and with them they can go into the lab. So this would be a prior step to the lab. So I think, yes, it's not so easy to convince the people from chemical simulations.
Yeah. Thank you very much, Gunter, for this great talk.
Thank you for having me.
Also ask the audience to please email you any questions that they might have about the company or the software itself. Yes. So I think we'll be happy to answer. Okay, so for the sake of time, it's time to move into the next speaker. So the next talk will be given by Stephen Hart. Stephen graduated in 1996 with a master in industrial biochemical engineering at Antwerp University in Belgium. After an interesting career in the industrial waste business and dangerous goods logistics, he joined the Umicore group in 2002, where he started as a logistics operation manager at the Umicore precious metals refining. From 2005-2015, he has been responsible for the supply of recycling electronic waste and recycling of industrial byproducts, and is currently responsible for different innovation projects, as well as for the supply of recyclables from special accounts. So Stephen has a broad expertise in recycling, and today we'll be hearing about precious metal recycling, a crucial step in the circular economy. Please, Stephen.
Thank you very much for giving me this opportunity and for this introduction. Let me first try to share my screen. There we are. Can you see the slides?
Yes.
Perfect. So indeed, I will give you some insights on precious metal, but also metal recycling. It's both precious metals and metals as they come in different industries and in different applications. And, okay. The first thing is the recycling. Let me first get rid of this. The recycling process, that we get some basics to introduce you about, so that we are familiar with some terms that we might further use in this presentation. First of all, it's important to know that metal recycling, actually, it requires a chain process. Many of you may be familiar with it, but it's very often very much underestimated. It's not one installation, it's not one company that's going to recycle metals. it's really a teamwork, a cooperation. It starts with collection, then you have dismantling or pre-processing and the shredding and things like that, and then end processing. And they are all interlinked. They have their benefits, but they also have their weaknesses, like losses of material in side streams, etc. And these operations in the recycling, they go, of course, hand in hand with other important operations like reuse, refurbishment, and of course also final waste that cannot be recovered. And of course, recycling efficiency of this whole process is determined by the weakest link in the chain. And maybe further down the presentation, it will be clear which one is a weak chain. Let's go a bit more into depth. What we understand with collection might be obvious to many of you, but it's good to understand what the job of each essential step in the recycling is. For collection, it's clear: accumulate quantity or critical mass, have sufficient quantity that certain installations can run well, economically feasible. They also do a pre-sorting into different categories, and what comes out are not pure materials or pure fractions, but different mixed grades of parts or whole equipment. You may know or not know this, but collection is often the most underestimated recycling step. So here you have already the answer to that question, maybe, because you have professional, formal, official collection channels, but you also have a lot of under the radar, substandard or unofficial collection channels that lead also to illegal export, etc. Then you have pre-processing, and a first important step, to my opinion, in pre-processing is dismantling. And dismantling actually is, you can say, the depollution or removal of critical fractions, like for instance, liquid from the brake, or oil from a car, or batteries, or toners, CRTs, circuit boards, etc. They should be removed very selectively prior to mass preparation. And as I said, it is highly selective, and that's one of the key characteristics or benefits of dismantling, but it is of course slow. And in line with the previous presentation of Gunter, I'm a full promoter of artificial intelligence. And because you have seen more and more very good promising evolution of the use of deep learning and sensor-based sorting and separation of different fractions. This is, to my opinion, an essential step in what we call efficient recycling of metals. There is a second important part when we talk about pre-processing, is the mechanical and physical treatment. And you might be familiar with it. You see it in a lot of scrap companies, you see big shredders and things like that. It's basically size reduction by shredding, separation by magnetic separation, eddy current, sieving, high density flotation and things like that, to come up with different sorted fractions. Important is that mechanical physical treatment, they focus on mass materials. So typically aluminum, iron, plastic, copper, nickel, these things that are present really in percentages in the end of life metal scrap or metal containing materials. So not critical metals. That's something else I'll explain later. One of the key benefits of mechanical physical pre-processing is of course also the high throughput. It's tons per hour. And what should come out is still impure fractions, complex or less complex, shredded or unshredded, but not pure copper, not pure iron or pure aluminum. That's too ambitious to have it at this point in time done by mechanical and physical treatment. So these steps are essential. They are important for mass materials, but they offer limitations for critical metals. And let's agree in this presentation that critical metals is a kind of a container term for what we among other call the EU critical metals. There's a whole list of critical metals determined by the European Union, like indium, bismuth, tantalum, etc. It's a huge list. But of course also conflict minerals, the 3TG, tungsten, tantalum, tin and gold are officially conflict minerals. Scarce and precious metals, they are all critical metals. And most of the time you find them in applications in very low concentrations, in grams per ton instead of in percentages, which makes it even more challenging for the recycling industry to have a good recycling of these critical metals. Then you have end processing, which is the general term for, call it end refining, etc. And they make use of chemical and metallurgical treatment. Yeah. I'm representing a company that is actually an end processing company. I'll explain briefly in a couple of slides further. You have typically hydro processes, pyro processes that are used to recover metals and to in a pure form out of the scrap material. An end process, bear in mind, is designed to recover a specific range of metals. You cannot recover everything. An aluminum smelter will not recover iron, an iron smelter will not recover precious metals. It is a specific range because you make use of the metallurgical and chemical capabilities, but also limitations, of course. What should an end processor at least have is a high yield recovery, combined also with a broad range of recovery. It should, of course, be of environmentally sound and also energy efficient. It becomes much more and more important that such processes are energy efficient. What, for instance, an example is of efficiency is so-called autogenic feed mixes, that are feed mixes that bear itself sufficient energy that you don't have to add fuel, etc. What is supposed to come out are then really the refined pure metals and materials that can have a second life as a raw material back in the industry. So again, specific range of metals, so it requires good pre-processing. An end refiner can only do its job well if the steps before, the shredding companies, etc., and the dismantling companies did their job well, of course. What is now the role of Umicore in the recycling? As I said, we are really an end processor. We have a history that goes back to the beginning of the 19th century, where we have a mining and metals background, and we have really evolved in the course of the decades to what we call a complex smelter, integrated smelter refinery, focusing on clean technologies and not just doing the mining and refining. For your information, in 1960, that's actually a very long time ago even, we received the first electronic scrap at our plant in Hoboken. Even if it was not yet officially done, recycling of electronics, we already received it in 1960s. And in 2000, beginning of the 21st century, we did a name change from Union Minière to Umicore, because we really chose for a technology treating secondary raw materials and also closing the loop in our downstream operations. At this point in time, Umicore is actually contributing in closing the loop, because closing the loop we don't do alone as a company. It's also, again, an industry cooperation in electronic components. So for instance, the plant I'm working for, Umicore Precious Metals Refining, they treat circuit boards and obsolete electronics. And Umicore electroplating can make new compounds and solutions that goes to the electronics industry. That's a nice closed loop. The second one is, of course, rechargeable batteries. Many of you know that we are a key player also in the electrification of cars and others. We also recycle the rechargeable batteries. The end-of-life batteries come to our division Cobalt and Specialty Materials. They put it in a pyro process for recovery of copper, cobalt, nickel and lithium, and then our rechargeable battery materials division can reintroduce this back in cathode materials. That's a good example also of a contribution in closed loop. I like this one, industrial catalysts. So typically the catalyst from petrochemical and pharmaceutical companies with PGMs, so the platinum group metals, platinum, palladium, rhodium, ruthenium also from time to time. This is a very short closed loop. This works fairly well. I'll explain later. There the industry directly brings it to recycling precious metals, and it goes then back into coating for new catalysts for that same industry. Last but not least, the same can be done with car catalysts, where Umicore recycles them in the same plant in Hoboken, and our automotive catalyst business provides new catalysts for the cars.
Sorry, Stephen.
Yes.
3 minutes, please.
3 minutes left only. No problem. So actually, what are we doing? We use in our process the characteristics of 3 metals, copper, lead, and nickel, in a smelting process that enables us to recover out of different metal-bearing scrap that you see on the left, electronic scrap and other material, that we can recover 17 metals out of. Mainly precious metals, silver, gold, platinum, palladium, etc., but also critical metals like bismuth, tin, antimony, tellure, selene are within the picture. What are currently the challenges? Give me 2 more slides and then I'm going to stop. If you look at the circular economy for the B2B business, and the B2B business is the industry that is producing its waste that goes directly into the recycling, you will see that it's a short loop, and it's actually also a fairly good life cycle efficiency, for the simple reason that it's an established industry. You don't have many losses. It's also typically high-grade materials. There's no distribution via the consumer, no collection problem. Whereas if you look at the B2C, so the consumer life cycle, there you have the production in blue. It comes at a certain point in time in the hands of the consumer. And then it becomes very difficult to get it back collected and get it back into the recycling chain. There you have a low life cycle efficiency due to this improper collection. I'm highlighting this again. This is an important one, but also due to the losses of critical metals because of the fact that because of the improper collection, it goes into channels with substandard processes. This is my last one. We did a reality check for the precious metals in different industries for global averages, so not European, global averages. The jewelry business, for instance, there you see a very high recovery yield. And that's normal because jewelry bears basically only precious metals. They are going to look for a high yield recovery treatment. The value determines it. That's pretty well known. Chemical processes, I showed you previously. It's a very good example of a short industry loop. There also the PGM recovery yield is high, thanks to this whole chain. Catalyst, for car catalyst, there you have a double effect. The value of the catalyst is high, so you need a high yield recovery, but it's consumer involved. You have different substandards under the radar channels where the material ends up. And last but not least is one of the main businesses where Umicore is active in. Electronics, precious metals out of electronics, on a global average, it's only 25% of the precious metals are recovered. What makes it happen a bit in Europe is the legislation, the WEEE legislation, but the fact that it's highly consumer involved, dispersed in the society, brings unfortunately many precious metals not into the right chain. Let me stop here, Ciao, if that's okay.
Yeah, thank you very much, Stephen. So we are a bit late in time. So thank you very much for this great talk on recycling, a key step in the circular economy, which is fundamental towards a sustainable future. So I think it was a quite clear talk. We don't have questions from the audience. In any case, I will ask the audience, for the sake of time, to email you to get some further insights on what you are doing at Umicore. Okay? Thank you very much.
My pleasure.
Thank you. So now we'll be moving to the last talk of this session, and the last talk will be given by Alina. By Alina Tomoiaga. So Alina is obtained his PhD in chemistry in 2007, yes, from the University of Antwerp in Belgium. Then after a few years working as a quality control manager and postdoctoral fellow in Romania, she became a project manager at the Alexander Ioan Cuza University in Romania. And since 2016, she is the scientific officer at the ERC Executive Agency, being responsible for the coordination of the evaluation process for project selection within the physical science and engineering panel. This is panel 5, and the panel for physical and analytical chemistry science. So Alina is a long-term collaborator with eYCN. She was present in the 7 ECC in Liverpool, where we strengthened the collaboration over the last years. And today, Alina will briefly present the funding opportunities under new framework program, which is called Horizon Europe. So Alina, please. We cannot hear you, Alina.
Excuse me. So thank you very much, Joe, for your nice introduction. Indeed, my name is Alina-Maria Tomoiaga, and I am a Romanian scientist working now for European Research Council. And we strengthened indeed the collaboration with the eYCN after the 7th Chemistry Congress in Liverpool. And I'm very glad to do this. I'm very open to all the time to talk to the young scientists. I think that they are the key for the next generation in research and innovation. So for the next few minutes, I will talk to you briefly about research and innovation funding opportunities under Horizon Europe. Of course, there is a lot of information you can find on the Commission websites. My presentation is just to summarize a little bit what concerns researchers and innovators across the Europe. So just one moment, I don't see. Okay. So Horizon Europe, as Joao also said, is the next research and innovation framework program. It will follow Horizon 2020. It will be implemented from 2021 until 2027. The proposed budget, currently proposed budget, is 100 million euro, and it's very
Sorry,
close
Alina.
to be.
Sorry, we are not seeing your screen, your slides. So.
Of course.
Sorry.
Sorry. sorry. Here. Yeah. My apologies. So now is it everything okay now?
Okay. Yeah, you can move on.
Good. Sorry. So it will be implemented from 2021 to 2027. The proposed budget, which is very close to be accepted, is on 100 billion euro. I am sorry for the mistake on the slide. And it will be known as #HorizonEU. Why we need Horizon Europe? We even need Horizon Europe more than Horizon 2020 because it's the target for Europe to do better in transforming transforming the using the brilliant mind of Europe to reach at least USA and other countries significantly better performing in research development and innovation. The Commission proposal budget, as I said, is of 100 billion euro with 25 billion euro proposed for excellent science. 52 million for global challenges and European. Innovative Europe gets 13 million euro and widening participation in European research area for 2.5 million. So how Horizon Europe will be built? It will be built on 3 pillars. The pillar 1 is excellent science, including European Research Council, Marie Curie actions, and research infrastructures, which are programs that are already known for you. Pillar 2, including global challenges and European industrial competitiveness with various clusters, starting from health, culture and creativity, civil security for society, digital industry and space, climate, energy and mobility, food, bioeconomy, and so on. And it will be mainly implemented by Joint Research Center. Pillar 3 will contain meaning innovative Europe. It will be, it refers to the European Innovation Council, European Innovation Ecosystem Systems, and European Institute of Innovation and Technology in Budapest. There will be two small other areas focusing on widening participation and strengthening the European research area. So Horizon Europe in detail and in more, let's say, easier words for us. Pillar 1, as I said, it means excellent science, means European Research Council grants, the grants funded by ERC, focusing on frontier research by the best researchers in Europe and their teams, who received almost 17 billion euro. It contains also Marie Skłodowska-Curie actions with almost 7 billion euro, and it will focus on acquiring skills for the young researchers through mobility and training. And research infrastructures, meaning integrated and interconnected world-class research infrastructures, who receives almost 2.5 billion euros. You know already that Ben Feringa is a big supporter of European Research Council, is now a scientific council member, and it's nice to see him all the time praising ERC funding for his Nobel Prize. Horizon, the pillar 2 of Horizon Europe is containing global challenges and European industrial competitiveness, and will focus on boosting the key technologies and solutions for EU policies and sustainable development goals. It will receive almost 53 billion euro, and as I said, there will be 6 clusters which will address different areas of research and innovation. Innovative Europe, pillar 3, is Innovative Europe, and will be implemented by European European Innovation Council, who supports will support innovation with breakthrough and market creating potential, who will receive 10 billion euro. European innovation ecosystems, connecting with regional and national innovation actors, who receive 500 million euros. And European Institute of Innovation and Technology in Budapest, who focuses on bringing key actors together around a common goal, and will receive 3 million euro.
Sorry, 2 minutes, please.
Yes, I will.
Okay.
I will skip to the with the small areas. And I just want to mention to you about European Innovation Council, who is the new funding opportunities for the people that want to bring research results to market. They will receive 10 million euro. You know already that the Commissioner Mudas was a big was the engine behind formation of European Innovation Council. And they will fund 2 complementary instruments, the Pathfinder grants, which means from early technology to pre-commercial, and these are the ex-FET open grants, and accelerator, meaning grants only or blended finance with money from the European Investment Bank. And is for people that want to bring, for companies, small companies that want to bring results from a pre-commercial stage to market and scale up. What about the European Research Council? What changes? What is new? We receive, happily, more, almost 4 billion euro more. There were created 2 new panels, one on materials engineering, one on human mobility, environment and space. There are panels that are redefined mainly in LS, in life sciences, some in physical sciences and engineering, and the SH2 panel, institutions, governance and legal system, from which SS7 was split. Applicants can receive €1 million as additional funding regardless of the call. And we will have interviews for advanced grants competition. I just wanted to stress out that the European Commission is very focused on open science across the Horizon Europe program. So open data and open access to publication will be a requirement. These are just a few links that you can access to learn more about Horizon Europe. Thank you very much.
Thank you very much, Alina, for introducing us this new framework program, Horizon Europe. So since Alina will be joining the workshop, the RC workshop in the afternoon at 3:30, so we'll skip any questions that you might have in this session, and you can ask them later on in the afternoon.
Yes.
So I just want to finalize this session by thanking all the speakers as well as the eYCN and the EUCAMS for organizing this fantastic event and this first session on future in chemistry. Thank all the speakers very much and all the attendees. And please now I would like to ask all the attendees to move on to the link that you have received for the session 2 that will be starting in around 5 minutes on grant writing. So thank you very much for joining, and see you in a few minutes.